cloud, LTE distribution, media distribution, the ABC technology in terms of cost efficiencies. In your mind, when you look at the gaming example, and that's basically a global situation versus a local situation where you're trying to enhance your local distribution and efficiencies in your network. How do we come about and how do we solve that global issue? Because if you have the best local delivery mechanism and that gamer in your country still needs that global delivery, how do we solve that? And then I'm going to throw it back to Jacob and see if you have some good ideas there. Because you know my issue is that middle mile within the internet. Back to that data server.
I'm afraid that I want to speak in English and I'm not Korean. 지금 순차적으로 좀 하고 있습니다. 천천히 말씀드리도록 하겠습니다. 게임 산업이 굉장히 중요하죠. 근데 한국에서는 좀 이게 뭐랄까
And to commercialize the gaming industry, it's quite tough, difficult. Let me elaborate the reasons. First of all, the government put a strong regulation, especially like gambling or drug, etc. The government is putting a strong hold against all of these industries because, you know, gaming industry make people very addictive. So in a way, we have some stumbling block in facilitating to develop the gaming industries. Of course, linking it with the advertisement industry, it will give a huge impact. What is gaming industry? As already the other speaker mentioned, it has close relationship with the latency. And also QS, it's also related. We have to give a lot of speed. Speed is critical element for the gaming industry. So we give advertisement first of all, and then if you push E button continuously, then there is a 2-second advertisement. If we do that, then the QS, the speed will go up. So that's the function that KT is providing. Overhaul in relations with the gaming. Yes. Those word first, word second, word third game makers are all Korean. Of course, there are Chinese makers as well, and I believe that Chinese industries are likely to have a bright future. And in relations with the online gaming, what I can say is that there's a rosy future. I don't know if I answer correctly.
No, that was wonderful, and I missed the first part of your answer because I had to get the translation. But the mobile cloud accelerator, would that also help in terms of trying to provide better response time outside your own country? Yes, okay. Jacob, I'll pass that to you.
So, first off, I agree that speed is the key here, speed within the network. And there's two areas where speed has to happen. Because let's say that we start to move processing away from the client in the home and put it into a data center. And let's say you have a massive multiplayer game where people are playing in the United States and they're playing in Korea. Well, what's going to happen is we're going to have one data center where they have a shared world, and that has to be located in one country. And then we have to have another data center where rendering is happening. And so when you start to separate data processing while at the same time having data exchange between players, what you need are tremendously fast pipes that are around the world that are able to then take that millisecond data that's occurring in the data center, which is telling where one person is versus another, send it to a data center in 2 different locations, which is then going to run to that final image. So it's a very complex problem. It's something that we on the software side actually do a little bit of work on because we try to hide aspects of latency. But it's something that in the future we're not going to be able to hide as much. And just to give you a quick example, when you're playing an MMO, when you're playing Final Fantasy 14, and I swipe at the dragon, and you see me swiping at the dragon on your screen, probably I'm seeing it faster than you by about 50 milliseconds. You would never know that because you're not seeing the same screen, but that could change in the future, especially as we start to unite rendering in different aspects of data centers around the world.
So it's like high frequency trading and with low latency.
Exactly.
I'm a little bit ahead of you.
Exactly.
So I have an advantage.
Yes.
Okay. All right, very interesting. I want to open up for
Yes, I have a question about LTE Advanced. In the roadmap it showed the carrier aggregation above 20 megahertz and also 8x8 MIMO as a future solution for high bandwidth connections. Can they comment on the challenges for the industry? Because if you talk to handset families, they really don't know how to put an antenna set inside a device.
You want to take that off, or Mr. J?
굉장히 좋은 질문입니다. 저희들이 이제 지금 LTE를 하면서
In implementing LTEA, the biggest challenge we are faced with is securing frequency. That's a big challenge. The frequency, the bandwidth we have is 1.8, 2, and 2.8. And in order to do the carrier aggregation, we need a lot of frequency, bandwidth. And someone mentioned 5G, and frankly speaking, 100 megahertz, the bandwidth, that's what we need. 1 giga is what we need. So I believe that, frankly speaking, the biggest challenge faced by all the industry is securing the bandwidth. And in China, I believe that TD-LTE is currently being pursued, and 3.5 gigahertz, 3.6 gigahertz low frequency is being provided, and TD-LTE is very promising within that frequency, because uplink and downlink, FDD must have uplink and downlink, while the time division duplex doesn't require that. And of course, if we go below the low frequency, then probably TD-LTE has a bright future. So in that sense, I believe that the government agencies and other relevant agencies shall take part in allocating a greater, more than 100 megahertz frequency and bandwidth. I believe that would be preferable.
Very good.
Right.
Would you like to say something?
That is just the logics of the question, because as Ms. G says, the most scarce resource on the planet will be frequencies, given all the things that we want to do. It will be more scarce than oil, really, if you have to say, to really stimulate the mind. And following that logic, even the 8x8 MIMO in LTEA will happen when it's sort of commercially viable, because the lack of frequency will lead us down to more and more powerful solutions to get more and more out of frequency. So even though we're sitting today struggling with putting that economics together, it's mostly an economic aspect of it, it will happen.
Question in the back there, please.
Thanks. I've got a question for Dan. The companion screen seems to be a pretty good mechanism for driving people back to live TV, given that it's contemporaneous with what's happening on live TV. I just wondered, is the BBC working on anything to do with time-shifted TV, given that so much is now time-shifted viewing, and that doesn't really quite work with what you've experienced. Is there anything that's happening? Do you know?
Well, that's part of the advantage of being, I guess, the programme maker stroke broadcaster, because in those situations, as I was saying earlier, you know what's coming next if you made it or you commissioned it, so you can prepare something that's quite elaborate, something that may appear as an overlay on a different angle to watch the output from, maybe on a tablet device, which you can then tap into. For the live situation, you're right, the network would have to be there, absolutely, 100%. We would like to provide, for some programming, a 360-degree experience, but in order to get that to the consumer contemporaneously, we're looking at an image that's 4 times the size of HD, which I think Mr. G has already emphasised this afternoon, would require bandwidth speeds uncompressed of around 25 gigabits per second, and is possible to get down to somewhere around 15 to 16 gigabits per second in a main broadcastable leading CERN. That's a bit of a push at the moment.
Okay. Question here, please.
你好，回应。你好，我是来自中国的记者，我是来自C114中国通信网的记者。那么我有一个问题想问一下爱立信的这个爱华姐。您刚才在演讲当中也是提到了这个异构网络对于这个运营商带来的这些挑战。那我们知道现在这个随着 IP 时代的这个到来，这个整个这个网络分层异构的趋势应该说是非常的这个明显。
It's becoming more and more pronounced and obvious. So there are challenges around the HETnet. So insofar as Ericsson is concerned, what are the new solutions from Ericsson to tackle HETnet challenges for operators? And for the Ericsson radio dot system you have mentioned, please elaborate on whether the Ericsson radio dot system will challenge the traditional systems.
Right, so to frame that, we're sort of running out of frequency. We need more and more different frequencies. We need to be able to combine more and more different frequencies. We're going to use technologies in the LTE, for instance, for carrier aggregation. We use more MIMO and all of that to be able to do more with less. At the same time, the experience, as we said, the distance between base stations today is providing an experience which is really originally made for voice. In other words, you don't need to scream louder just because you're further away from the base station. So, but in data, that's very different. There you really have to scream louder. The throughputs are getting lower and lower the further away you are, so we need to densify the networks. Those are the main reasons behind driving the heterogeneous network idea. The other main reason is also that coverage in new places, in homes, in shopping malls, in areas where there was, in offices, is another very big challenge. In order not to create, and now it will be a little bit techy for the radio part here, but in order to not create too much interference in the networks, we need to be able to coordinate more and more within the frequency spectrum. In other words, it's very useful to have the exact same anchor point for that coordination inside the network. In other words, the baseband modules of the base stations or something like that. We have argued for a long time that it's extremely important to do this. The Ericsson radio dot system, I don't know if we have a dot around here somewhere, someone can hold it up, but that basic product is then signaling back to the same actual baseband that the macro network is using, creating a full coordination, meeting some of those challenges that are in there. There are other technologies such as COMP, for instance, that was mentioned also by Mr. G, which is a key technology in order to make a better experience when you're at the cell edge. Those kind of things has to also be coordinated by running through the network. So we think that it's not so good idea long term when frequencies are getting so scarce that you just put out a lot of radio transmitters that are uncoordinated. It will raise the noise floor, which will not be so good. So that's why we advocate that. Those are the challenges. We are sure that we have a good strategy to meet that. Thank you. Thank you for the question.
Question in the back, please.
Hi, I'm Neha from Gartner. This question is for Mr. Evolson. You talked about latency, reducing latency, and my question is basically is Ericsson also looking at moving the core and the radio functions of the mobile network to the cloud, not only to reduce latency, but also, like we are saying, that the data consumption is going to increase to reduce cost to deliver data to the users. So are there any trials going on? And if so, what's the kind of response that you're getting from the operators?
Okay, great question, because I think every speaker here can talk about latency. It's been very, very obvious through the entire afternoon that there was a lot more discussions about throughput. If we go back a little bit now, it's very much about latency and new applications using that. So obviously Ericsson is working very, very hard on that. I can say, perhaps for Jacob's benefit, then that in 5G we're looking at latencies below 1 millisecond. But now that is not really happening yet. But we're going there. So, and then the other question is, are we then looking at new network architectures to be able to meet that? And yes, we are. I mean, you will hear later in one of the breakout sessions later this afternoon by Eric Ekkoden, who will lead a session on service provider SDN, where we will go through and look at how we can do that by horizontalizing the network instead of vertical. Today, the vertical way of building the network is actually creating a lot of that latency that you don't want. And that means bringing the cloud actually in the network, taking your data center and being able to give the opportunity for your data center to distribute virtual machines through a network. That would be amazing if we can do that.
That's actually very similar to a vision that we need for our interactive media.
That's the vision we're driving. So what we want to do is to be able to do that in the next generation networks. That will require us to virtualize the core, if you will. Ericsson is on the road to do that. So in the next 2 years, we will be completely virtualized through our different applications, and then adding the OSS layer to be able to address the horizontal network instead of these vertical pipes that we have today.
A distributed data center. You don't have to long haul it back.
Right.
Simple as that.
That's the idea.
If we can do it, let's move forward. And both of you asked for the puck. Will you be going through this tomorrow? Will we have a film and describing the puck and how it works tomorrow?
There will be some talk about it tomorrow.
Okay, so we'll talk about this tomorrow. This is the in-building solution that we're just describing. Next question, please. Any? All right. Any questions amongst yourselves? I would thank all of you. It was extremely interesting to have a discussion. Presentation. Great. Thank you.
Thank you.